start with storage fundamentals playlist. Okay, so it is covered in depth, all the things, all the storage basics that you know that needs to be covered. It is there. Okay, and let me go to the L3 channel. 1 second. uh, this one right here. Analytics. Okay, yeah, please accept other people. Yeah, yeah, so I guess so. You need to first, as I said, you need to first study the storage fundamentals. Then you can go with either batch 21. So this is only L2. Okay, because last batch we did not did L3. It was so we did only L2. So this is L2 plus L3 is there, and here L1, L2, L3, all the things are there. Okay, so you need to study that. So today we'll start storage basics. Okay, storage basics, and it will be very useful for people who are not from storage background, and slowly we'll progress into NetApp and everything. So let me share you that. 1 second. So if you go here, if you go to the syllabus, then you see here. Initially, I'll teach you storage architecture. All the basic part, so that anyone who is not from storage background, they can understand. And then I'll teach you all the NetApp stuff. Okay. In last batch, for the NetApp stuff, I did lot of networking session. It's not required actually, and every batch will be different. Okay, because it depends on my present use cases, present issues, whatever I have solved. So you can see here there are a lot of networking classes I've taken. Okay, normally it's not required, but so let us start the training. It's 9:30, right? Yeah. And one more thing I wanted to tell you is that in case any of you are not able to understand something, they can ping me one to one, ping me in the group. They can point it out during the session. And if you check my group, right? So basically, uh, if you check, let me just minimize this a bit. If you check here, right, top, you see a lot of people will ask me about question, right? So you can see I answered them. Okay, it's not a one-time session. Okay, so a lot of things you can see. Okay, so you can see here. So everything will be given to you, and this is the Hitachi, and this is storage automation. So this is different. So let me go here. So let me start one by one. Okay, basics. Here, this was just an issue which I uploaded in the Hitachi. That's something else. So you have to understand one thing. Please accept Narayana. Please, I have to again. Yeah.
I just wanted to know whether the recording started.
Yeah, recording is going on. It is going on. Don't worry. I'm just minimizing it. Let it keep. Okay. So basically, as a data center person, as a storage guy, you have to understand the different elements of data center. Okay. I don't know why I'm not able to accept him. He has some problem with his networking. Okay, please somebody ping him. He has some issues with networking, and that is the reason I'm not able to accept him. Second, let me ping him. Narayana. Let's check. Okay, so let me try again. He has some networking issues, okay? See, not able to admit him. Anyway, let us start. So you have to understand the core elements of data center. So what are the elements you have? Okay. So there will be application. There will be application. There will be database. There will be server and OS team. OS. Okay. There will be network, and there will be storage. Okay. There will be storage. Can someone please bring this guy? Because he'll keep on. I don't know what is happening. Okay, so here application you have to understand there will be a lot of different applications. It will require some database. Okay, it can be SQL or NoSQL, and you will have your servers like Unix servers, Windows servers, ESX infrastructure, different servers, and you'll have your network and storage. All these things will come into picture. Okay, so especially for performance issues, right? Performance analysis. When you do performance analysis, when some performance issues come to you asking that application is facing slowness or performance bottleneck, you have to understand that that may not be the issue from storage end. You have to do a storage thing. Like if it is a SAN, then you have to check a lot of things which are related to your SAN switches. If it is a NAS, then network is involved. Okay, you have to understand that. Okay. Okay, so what happen is basically you have to understand the data center component, and you need to understand that that we have different products, storage products. Okay, we have SAN, we have NAS, we have object storage, we have object storage. Okay, we have, you can say, cloud storage. So you have to understand different things. Okay, so let me share one of the things. So related to SAN is nothing but storage area network. Okay, so it will have your storages, and you'll connect the storage front-end ports. So basically the storage will have two kinds of ports, front-end port and back-end port. Using front-end port, you will connect it to switches, and you'll connect the host HBS to switches, and you'll zone them. Okay, and that is specifically for host allocation, like allocating storage to host. And also if you want to do replications, then what you need to do, you need to do zoning between front-end ports, source arrays front-end port and destination arrays front-end port. Okay, and for NAS you will not have any SAN switch. Whatever Ethernet switch you have for your networks, you can use those, you can leverage those. So SAN is, it will be like additional cost is there because of buying the SAN switches, but NAS is not there. So what you will do, you will connect the server NIC with the Ethernet Ethernet switches, and you'll connect the Ethernet port of your NetApp cluster with your Ethernet switches. So that's what it will, the data will be transferred over the network, and so that there will be slowness, it will depend on the network performance. Okay, and also one more thing you have to understand, that is about tiering. So in a storage you will have different kind of tiering, higher tier, lower tier, depending on the application. Like critical application, you'll put it on higher tier or secondary tier. So all these things are there, which I'll discuss in NetApp. Okay, the different product, like different vendor will call this in different way, but so NetApp is like, we have the fabric pool NetApp. In Hitachi we have different concept like dynamic tiering. Okay, so different. Okay, so let me just share the diagram and show you. One second. Image. Okay, go to images, and this is how I can explain easily. Yeah, this is probably a little bit better. So you can think of this, you can think this, maybe, one second, just give me a second here. Storage area network. Let us go here. Okay. So basically, what you'll have in SAN. In SAN, what you'll have. Okay. In SAN, you will have your. This is a better one. You will have your storage boxes. Okay. And in storage, you will have the fabric that you have. The fabric that you have, it will be collection of switches. You will have fabric A and fabric B. Why? Because being a storage admin or being a data center guy, you always have to ensure that you do not have any single point of failure. So you'll have fabric A, fabric B. You will connect the suppose you have a NetApp array and it has two nodes. Okay, so it's a cluster, two nodes. So node 1, the IPC ports will connect to the fabric A switches, and node 2 fabric based switches. Fabric is collection of switches, and you'll connect the HBA. So one host will have two HBA, so one HBA with the fabric A and HBA fabric B. Okay, so that is basically SAN. SAN is basically you are using the SAN switches. Okay, you are using the SAN switches, you will get better connectivity, better speed, and you are using FC cables. So you will be connecting the FC cables from the storage front end port to your Brocat or Cisco or MACdata SAN switches. Okay, let me just show you Brocat. Yeah, this is better actually. This is better, yeah. So you can see here, you can see this is a NetApp box. You see controller 1, controller 2. Okay, so you can see here, two node. Okay, so node 1, node 2, and this is your SAN switches. So one fabric is having two SAN switches. Normally it will have many. So during our switch classes, I will discuss about core edge fabric, different kind of fabrics, fabric topologies. Okay, then I'll discuss. Okay, like, and lot of things I'll discuss related to switches. So here what is being done, you see the front end port, the FC port, you're connecting the fiber channel port with the SAN switch, and this is FC cable that we are doing, and you're using the FC cable to connect to the HBA. You can have CNA also, converged network adapter, CNA, which will act both as an HBA and NIC card. Okay, HBA is for SAN and NIC is for NAS, network interface card, host bus adapter. Okay, so these are the things, the basic things. So you are connecting the HBA with fabric A, you are connecting the HBA to with fabric B. So that's what you are doing. Okay, and then you will do zone and everything. So this is for the SAN. Okay, I will discuss. So in NetApp we'll discuss about SAN, NAS, object storage, cloud storage, NVMe, lot of stuff. But what I'm trying to say is that suppose you are buying a NetApp product, right? So NetApp product will have different kind of products. They have fast products, which is a hybrid array. Okay, hybrid array. Why? What do you mean by hybrid array? It means you'll have SSD and mechanical disk. Okay, mechanical disk means which will have spindle, platter, like it will rotate the disk, right? Rotate the platter. So you'll have, it will have mechanical delays. So whenever data is being requested from by the server from storage, and if it's not in the cache, it will be staged from the disk, and if it is a mechanical disk, it has to locate the data right on the platter. So header will locate the data right. So that will say that cause seek time. Okay, and that will take some time. But SSD is like flash drive, which will be like very quick, similar to cache. So if all the disks are flash disk or SSD disk, then the performance will be much better compared to the, in mechanical hard disk you have SATA, you have SAS, Okay, SATA is like 7.2k RPM. RPM means rotations per minute. So how fast the spindle can rotate per minute. Okay, and SAS will have like 15k, 10k. Okay, and different kind of SAS is there. B SAS, NL SAS. Okay, B SAS is like kind of like bigger, so it is a little bit smaller, and you have different kind of form factor. Whenever you think about drives, mechanical drives, flash drives, you think about form factors. 3.5 inch disc, 2.5 inch disc, these are called form factors. Okay, so you have to understand that we have different kind of models in NetApp. So the fast model that we have, it's a hybrid array. Okay, and then you have AFF, all flash array. Okay, and this will have all SSD disk or FMD disk, flash disk. Okay, so these are here, this FAS and AFF, what does it supports? Which protocol does it support? So here a lot of people has joined, right? So one second. Yeah, Che, can you tell me which Che and Sutish, what are the
I,
protocols that NetApp supports in ONTAP? I'm talking about ONTAP. So ONTAP is the operating system of NetApp. Okay.
yeah,
So
sir.
what does it
iSCSI
support?
SAN
iSCSI is part of SAN. iSCSI FC, you mean FC.
CFC,
NFS, CIFS, NVMe,
F3 also.
S3. Yeah. So these are the things support. So whenever you are buying any kind of like models, if you go to the NetApp and there is a hardware universe, okay, you need to log into the support IDs, and then you'll be able to get specifications of different models. You'll be able to understand from there. It's called hardware universe. Okay, and then you can see different kind of FAS boxes 2520, and some latest boxes came in our environment. AFA barriers are there. Okay, so but these are having same operating system, that is ONTAP. Right now, what is the version of the ONTAP that we are running? Can anyone tell me? 9 point?
9.17.
Yeah, but I have 9.16 in my environment. Okay, maybe I have to update P3. I think 1 P3. I think. Okay, so you need to always understand that there is a life cycle management that you have to do. Life cycle management means you have your NetApp arrays, you have your switches. Every quarterly you have to update to N-1 stable version. You should not go to the latest version, always N-1 stable version, never to the latest version. You can go to the latest version, yes, but for storage tools. Storage tool means Occam and everything. I will discuss about those tools. Okay, so what I'm trying to say is that, like, unlike Hitachi or other arrays, other vendors, NetApp one model, it supports. For SAN we are using two protocols, iSCSI and FC. For FC we need to have the FC switches, the SAN switches, FC cables. For iSCSI we can use the existing infrastructure, the network infrastructure, the Ethernet switches, no need of purchasing any FC cables or FC switches. Okay, it will also be like the SCSI will be encapsulated over the IP, and it will be sent across the Ethernet, but it is SAN only, but the speed will be, there will be performance bottleneck compared to the FC. FC is much faster. And then you have NFS. We also support FCOE. I did not say that. Apache Ethernet, but it's not required. But we do not use it. Okay. So normally we don't use the FCOE nowadays. It was quite hit 8 years ago. People are saying that it's the next big thing, but it flopped actually. So for SAN you're using iSCSI and FC, and for NAS you're using NFS, network file system, and you are using it for your Unix servers, whether it is AIX or HPUX or Solaris or Linux, Red Hat Linux, Ubuntu Linux, you're using it. Okay, and CF is only for Windows, common internet file system. Normally they used to call it as SMB instead of CMB. Is called as SMB, which Solaris, which is Sun Microsystem has, I think they invented. Okay, and then we have NVMe, which is also like where we can use the some inferior hardwares but get better performance. Okay, and we have S3, which is object storage. S3 means simple storage service. So yesterday I had an issue with HCP and I was clearing the deadlock. So what I had to do with the user that we created, right, permissions was not reflecting. So every object storage will follow AWS service policy. That AWS service policy is there, which is in JSON format. Okay, and the same thing we need to do in NetApp. It's easier compared to Hitachi. You can just edit in GUI for the storage grid. Okay, so object storage. So in ONTAP, as I said, in ONTAP, FAS and AFM NetApp, you have S3, which is object storage. That is the inbuilt object storage. But if client wants, if project wants, they can also buy another product, which is called as storage grid, which is also object storage solution. Okay, they can also purchase this product. And NetApp is also having another product, which is ASA, all SAN array, totally SAN. Okay, all SAN array. And NetApp has collaborated with different cloud vendors, AWS, Azure, and GCP, and it has created their products in cloud. Like you have your FSx ONTAP, AWS FSx ONTAP, Azure NetApp Files, you have GCP NetApp Volumes. So there, whatever NetApp features are there, like SnapMirror, snapshots, you can use that in cloud. So there are different features are there, different plans are there. Like you can have cloud at the backend, you can have your on-premise. On-premise means it's like hardware. Okay, like you have your NetApp box and you can connect to cloud. The storage will be like the data will be kept in the NetApp only. And also you can have cloud. The cloud you will run the NetApp commands, but it's using cloud storage only. Okay, like GCP NetApp Volumes. Okay, so different products are there. Okay, so you have ONTAP will, like FAS, AFM will have ONTAP. Then you have storage grid. Okay, then you have all SAN array. Then you have NetApp CVO, which is like Cloud Volume ONTAP for AWS, Azure, and GCP. And you also have E-Series, which is having Centricity OS. Okay, not ONTAP. And the E-Series will support only, I need to check, I think RAID 6. Okay, so we'll also discuss about different RAIDs. Let me just drink some water 1 second. I do not want to go to detail about NetApp now. I just want to clear the I just want to clear the basics, storage basics. Okay, so host is, you have to understand about the host. Okay, so you can have the host like Windows or Unix. You will have CPU. So whenever you are having some prophecy or something, it may be some host related, maybe it needs patching or something. Okay, so you need to have little bit of understanding about host. Okay, like suppose you are, so whenever you are using SAN, right, so what you are doing, you are doing zoning. Zoning means you are making the connection between server and storage using SAN switches. It in some situations, like long back, you would see DAS storage also. Okay, DAS is what? Direct attached storages. Okay, suppose you do not have SAN switch, you have your storage and you have your server. You can connect the HV directly to your server's front-end port. Okay, front-end port. Okay, so what will happen in that case? Also, you'll be able to allocate the storage, okay, to server. But in that case, what will happen? You are able to use that front-end port only for that server only. But if you're connecting the front-end port to SAN switches, if you're connecting the server HB to SAN switches, you're zoning, then this same front-end port you can use for many other servers. So that is a use case for using SAN switch, not the primary use case. Primary use case is redundancy. Okay, redundancy is there because if you are having a 2-node cluster, a NetApp cluster which is having 2 nodes, one node is down, then you have the another node which you have used to allocate the storage to. Okay, so the server will have continuous access to storage even if one fabric is down or one node is down or one HB is down. So you're getting node level redundancy, you're getting fabric level redundancy, you're getting HB level redundancy. So you have to understand that. Okay, you have to eradicate every single point of failure that you have. Okay, so that you have to understand. So what you are basically doing here, we are using the front end port, right? But we'll have some back end port also.
So
From the back end port, you will have a
wire is
connector,
sharing a
and
front
from
end
the
port.
connector you will connect the disk.
That's how it called,
Yeah.
or
No. We'll have different
oh,
topic for the front end port, back end port. Okay, it's just I'm just giving you overview. We'll have that. Okay. When I'll show you the NetApp hardware architecture, then I'll explain. Then I'll show you the back end ports and front end ports. Okay. So don't worry about that. So what you have to understand, that we have you understood, right? The front end port is for your host allocation and also for replication. You understand, right? And the back end port is for to connect the disk. So which is back end, which is storage internal things. Okay, you got it, right? And let me just see if I can give some disk drive architecture not here. Yeah, disk drive. Okay, so these are this disk drive. You can see that this is the platter here. You can see platter here. Okay, and this is the spindle here. You can see here, this is the spindle. Okay, and you can see this is basically you can see here, this one basically the actuator. Okay, you can see here, and this is when the data is, suppose storage is or host is asking some data, right, which is not in the cache. Okay, cache is similar to RAM that you have in mobile or laptop. Okay, random access memory, which is VRDL memory. Okay, so it's not in cache, it's not in RAM. Okay, as you can say, so it will look in the disk drives, right? So this actuator has to locate the data. Okay, here, so it will rotate, as I said, there is RPM, right, rotations per minute, depending on whether it's SATA, SAS, what SAS you have, whether 7.2k means 7200 k per like rotations per minute. Okay, so depending on that. Okay, so if it's better, if it's having more speed, then it will locate the the data faster. So it will have mechanical delays because it has to locate the data, right? But in case of flash drive, it does not have this. Okay, it does not have this. Okay, so you have to always understand, so what kind of disk you are using, whether you have to understand about your own storage. Like here in my environment, I'm using AFF, the all flash array in the source. I'm using lesser expensive or less powerful array like FAS 2520, I think I'm using in the destination. Okay, target. Okay, so these things they will not ask you. The reason why I'm telling you these things, because when I do the IOPS calculation, I will do the IOPS calculation, right? Then you need to understand what is RPM, like spindle speed. Okay, the spindle will speed like say 7.2k RPM, so 7200 rotations per minute, or 10,000 or 15,000. Okay, so you need to understand that. And some people will ask you during the interview that what is form factor. So as I said, large form factor is 3.5 inch disc and small form factor is 2.5 inch disc. So they will ask you these questions. So you need to understand the basic stuff also. Okay, but normally when the SSD, like SSD is now very cheap now. Okay, and after it came, right, what happened, the dependency to cache has been reduced. Okay, initially it was it was a lot of dependent on whether the data is in cache or not. Okay, so it was a lot of dependent on that. Now it's not, we don't really care because SSD is very fast, and that's what is happening. Okay, now let us give you an I need to show you some architecture. 1 second. Cache cache, storage, cache. Let's check if you have some get. Yeah, I'm getting something, but not good. Not very good, but I had taught people about this thing, but I wanted to show you the picture actually. Just give me a second here. Storage.
In last class, it was intelligent storage system. Last class, we used the
What is it?
intelligent storage system as a keyword.
Yeah, I think that is better. Yeah, intelligent storage system architecture. I think that might come. I think you were right. Yes, it came exactly. 1 second. So as you can see here, this is just the basic thing. Okay. In NetApp diagram, when I'll show you that where the front-end ports are located, back-end ports are located, how it's connected. So first here, you just have to understand this is an intelligent storage system. Okay, we had like DAS and everything back in 2002 or something. Okay, we used to do like to save some money in 1990s, but nowadays it's people are using intelligent storage system. So storage system will have different models. Okay, you will have entry level, which are lesser expensive, very cheaper, and then you have mid-range, and then you have enterprise level, which is more expensive. So entry level will have less cache, less ports, okay, lesser performance. Mid-range is like kind of mid in between, and enterprise is basically the one for which you use for production. So if suppose you want to use to keep your backup somewhere in storage, right, you'll be going for mid-range or entry level. Okay, if you're using for production, you'll go for the enterprise. And also I forgot to say, I'll teach one more thing in NetApp, which is ONTAP select. ONTAP select, this is software defined storage array. Okay, so what does it mean? It does not have its own hardware. So what you can do, you have your Hitachi storage, you have your EMC storage, and what you're doing is you are allocating it, you are allocating you're allocating it to your ESX server. Okay, and what you can do, we can use the ESX infrastructure to create our ONTAP select nodes, which is basically software defined storage array. So we are using the ESX infrastructure and some other storage, but we are not actually buying NetApp hardwares. Suppose you already have purchased a SAN product and you do not want to spend money for buying the NAS hardwares. Okay, then what you normally do, that you buy ONTAP select. What you do is not a license, it's like you need to buy support. And suppose you want 2 TB storage, right? The storage you are giving from Hitachi, fine, you are allocating the Hitachi, you are connecting the ESX server to SAN switches, you are connecting the Hitachi to SAN switches, you are doing zoning, you are allocating the storage to ESX server, you are creating the data store, everything. But that same storage, when you want to use for the software defined storage array of NetApp, what you need to do is you need to buy license from NetApp to make that storage visible. If you want to use 2 TB, you need to make a license for 2 TB. You need to get a license. You want 3 TB, 3 TB. So you need to, until unless you have that license, even if you share the capacity, right, it won't be visible. You won't be able to use that. Okay, in like all other storages record as storage pool. So you will have disk, you will add the disk together, you will create a pool, and from pool you will create everything, whether NAS or SAN or object, you will create those things. Okay, and that pool concept we call in NetApp we call it as aggregates. Okay, we'll talk about all these things. Okay, slowly we'll go. Okay, so let me just go to the picture. You can see here the intelligent storage system. Okay, so this is Intel storage system. It is not DAS. You can see here storage network it's showing. Okay, now you have to understand. So this storage system, it will have 4 key components. What are the key components? Front-end ports, cache, you can say front-end, cache, back-end, okay, and physical disks, whether it's SATA, SAS, anything, okay. And these are hosts. So suppose from host you will receive an input output, okay, and it will go to the front-end port, and then it will go to the cache. If there is data in the cache will, from the cache the data will be given, it will go to from the front-end port to the host, okay. And if there is no data in cache, then the request will come to the backend port, and backend port from the disk the data will be staged to the cache, and from cache will go to the host, okay, accessed by the host, okay. So this is the normal thing. So what is happening? The request is processing through cache from the front end port, okay, and if the data is not cache, so from the backend port it is taking from the physical disk, and this process is called staging the data to cache. Whenever the data is not in cache, it will come from the physical disk. It is called staging the data, and it will take, if you are using mechanical disk, okay, which will have platter, actuator, arms and everything, so it will take some time for the data to go to the cache, right? It will take some data, like it will take some time, and that is called latency. You will have some latency. Response time will be much more. Normally 5 millisecond response time is actually recommended, less than 5 millisecond, okay. But suppose your application is giving 5 millisecond response time, yes, but suppose at a certain point in time you see the response time is like 15 millisecond, 20 millisecond, 30 millisecond, then you have to check suddenly what happened, okay. So what I do with my students is I take a session where separately I discuss about SAN performance analysis and NAS performance analysis, because it will be completely different, okay. So you see the front end port, right? So this is the front end, right? So front end, what it is doing, it is providing the interface between the storage system and the host, okay. So what front end port will have, it will have front end ports and it will have controllers, okay. And this front end port, you can have Ethernet port, or you can have FC port. If you are having Ethernet port, you can use that for iSCSI, or you can, okay. In case of SAN, here we are using storage network, right? We'll use it for iSCSI, okay. And in case of FC port, then we need to connect that to your fabrics, FC switches. So it's whether it is Brocade or Cisco, okay. And we always have to make sure that we have redundant fabric, so we can connect the front end port. Like suppose this is like 2 node cluster, okay. So one node, second node. So first node will go to the fabric A, and second node will go to the fabric B. So you have redundant connection. So the storage will always be available to the host, okay. So you have to understand that, okay. You understood this front end port concept, right? Because this is very important. Without this you will not understand the storage. And then you have cache. Cache is a very important component in storage. So as I said, if host is requesting the data and if it is in cache, this is called as read hit. That means it does not have to look into the disk. If it is a mechanical disk, then the delay will be much more. If it is a SSD or flash drive, then the delay will be lesser. The latency, the response will be much quicker for SSD drives, solid state drives, or flash drives, okay. So what is happening? If the data is in cache, then the data is given from the cache, right? So whatever mechanical delays might have happened, if the data is being given from the disk, it is devoid of that, okay. So because whenever the data is looking for some mechanical disk, right, it has to the actuator arm, it has to locate the data in the platter, okay. So you will have some seek time, right? Seek time means it times to take the seek the data, the block which is on the platter, and depends on the RPM also, okay. And whenever suppose you have some input output, right, it is seeking the data, and then another input output request is coming seeking the data. So the requests are being queued, okay. Requests are queued, okay, which is not a good thing. And every front end port will have some queue depth. Depending on model, depending on vendor, the queue depth will have like how many input output can stay in the queue, If it's more than that, then you'll face latency issues. You'll get congestions. You'll get performance bottleneck. You don't want that, okay? And if your cache is big and you have proper, you know, proper tiering concept, right? Tiering means your cold data is in lower tier and your hot data is in higher tier. Okay, high tier means you can create see, different storages having different concepts, Hitachi and NetApp. So in NetApp you can create flash pool. In that, what will happen, you have your normal mechanical drives, and then you add SSD, and that is only for the random read and random write. It is not good for the sequential read, okay? It is not good for the, so when you add the SSD drives and make that pool a flash pool, whatever mechanical drives you are having, that will contribute to the usable space. Whatever SSD drives you are adding to that pool, that will not expand the size of your storage pool. We call it as aggregate in NetApp. Okay, so, and that will help you with the read and write performance, random read and random write performance. Okay, and so different things are there, and there is one concept of fabric pool where we can we can send the data which are like snapshot data, the local backup data and the cold data to the object tier, and we can keep the like frequently accessed data in the higher tier SSD disk, okay, to save bugs. So, okay, so that is also we can do that. Two things that we can do: storage like flash pool and fabric pool, okay, in NetApp. In Hitachi is completely different. We have relocation cycle, modding, so it is completely different. You don't have to know that. Everything is different, but you have to understand the the importance of cache, okay? And suppose you are writing, suppose host is writing some IO, right IOs are coming, it is writing the data, and cache is having space, so it will write the data in the cache, and then once it writes the data in the cache, host will get acknowledgement that the data is written. Host will not know that data is not written in the drive. So at some later point of time in NetApp, it's called as CP points. I'll discuss about the consistency point. So the data will be written on the disk, okay? But this data, whatever data is written on the disk, right, host will not know, and host will not face that latency problem because of having the data written on the cache, okay? So this is something you have to understand, okay? So what you are saying is that whenever the read request is coming and it's in the cache, it will be given to the host, okay? And suppose the read request is coming, it is not in the cache, it will go to the physical disk and then it will go, okay? So this read hit, if it's in the cache, that is called as read hit. And read miss, if the data is not in the cache, it has to be staged from the hard disk, aggregates, then it is read miss. So when you are doing performance analysis, you have to also check about the read hit and read miss, okay, graphs, okay? We need to check this, okay? And write operations, what is happening? Suppose you are suppose some write IO is coming from the host, right? It will be written to the cache and the acknowledgement will be given, okay? And so it will take far lesser time than it would have been taken when the data was written on the drives, okay? So it is much better, okay? But it is called write hit and write miss, okay? You have to understand that, okay? So data is written on the cache and acknowledgement is being sent to the host immediately, and later point of time data will be written to the drives, which is called as destaging process. Here the write response time is much faster because mechanical release, it's happening here, right? But host does not know, okay? But there is a problem. Suppose the data is in cache and then some outage happens, so you will have some problem, you'll have some some cache fails or something, then the data will be lost, right? So in order to avoid that scenario, we have cache halting and everything. I'll discuss about that. So we'll have some SSDs where the data will be there, okay? So in case of NetApp is different. It's will use NVRAM and system memory. System memory is volatile, NVRAM is non-volatile, okay? That means that when the storage is down, system memory is gone, but NVRAM will have batteries and it will it will be there, the data will be there in NVRAM. And we also mirror the data in other node in the same cluster of NVRAM. Okay, NetApp is different, but other storage is using vaulting technique, okay? So you'll have some SSD drives there, the data will be kept, Okay, so this is your write back cache. Okay, and there is a concept of write through cache. What happens in that? So write write IOs came from host, and the data is written on the cache. Okay, and whenever the data is written in the cache, immediately the data will be written to the disk, and then the acknowledge will be given to the host. So there is a round trip delay is there. So the data is committed to the disk whenever the data is arriving to the cache. So here the data loss chances are low, but the rise response time will be much longer. Latency or the response will be much slower. Why? Because if you're using the mechanical disk, it will take some time to write onto the disk. Okay, so you have to understand that. Okay, I guess you are able to understand this thing, right? This is very easy and very important. And NetApp main thing is cache mirroring, the NVIDIA mirroring. I'll discuss about that. Okay, so I will discuss about how the write and read IO is processed in NetApp. I'll discuss about that. Okay, and then you have backend. 1 second. Then you have backend. You can see here. So here this backend, this will provide an interface between the cache and the physical disk. Okay, the backend will have two components: backend ports and backend controllers. Okay, controllers are nothing but the CPU. You can say that. Okay, so what backend will do? The backend will do the data transfer. It will control the operations of data transfer between the cache and the physical disk. Okay, so what will happen from cache? The data will be sent to the backend, and like from cache it will send to the backend, and from the backend to the disk. Okay, this is called as destaging process. Okay, and staging, whenever the data is needed, not in the it has to be requested by the host, then it will come from the backend to cache. Okay, so this is also happens. Okay, and you have to understand whenever you are using storage write, disk write, there is a concept that you have to remember, which is very important. The concept is RAID, redundant array of inexpensive disk or independent disk. Okay, you have to understand that RAID is very important, and using RAID you can understand which RAID you have to use for sequential IOs, which RAID for random IOs, which is better for read, which is better for write. Okay, you have to understand which is better for like to have better redundancy, like suppose you are having simultaneously 3 disk failures, so which RAID can protect you against that scenario. So you have to understand that. Okay, RAID, can anyone tell me the full form of RAID? I just told you what is the full form of RAID. Sutish, Che, can you tell me what is the full form of RAID? It is very easy.
Random
Redundancy array independent disk.
Yes, redundant array of independent disk. Normally, if you're having experience of 8 years, 9 years, they will not ask you these questions. But if you're having experience less than 5 years, they'll ask you basic questions to understand. You understand whether you understand storage or not. Because if you're not good with the basics, you'll have trouble understand, like doing the troubleshooting. You'll have problems. Okay. So what happened is that the mechanical hard disk or SSD disk, whatever you're using, right? Suppose you were using a mechanical hard disk, right? So it will have some mechanical wear and tear, right? Because it is rotating and everything. Something will be there, right? And environmental factors will be there, like cold or hot. Something will be there, okay? And due to which it can fail, and the hard disk failure can result into data loss. So what you can do to avoid that thing, storage, the IEEE community, so they have invented RAID. Okay, redundant array of inexpensive disk. So what they're doing, they're just adding some disk together, and they're giving fault tolerance and redundancy. If you lose the data, like suppose 1 disk, 2 disk, 3 disk, you'll not, if you're losing the disk, you still not lose the data, depending on what RAID you are using. Okay, so I'll discuss about different RAIDs, but for NetApp we use RAID DP, RAID TEC, and RAID 4 for ONTAP, and RAID 6 for Sentry City. Okay, E series. Okay, and that RAID 6 we cannot change, it comes built, like pre-built. We cannot change, it's just one, we only have one option. Okay, so let me discuss about RAID. So one by one I'll discuss with pictures. RAID, I'll start with RAID 1, RAID 0. Let's start with RAID 0. Okay, you see a better picture here. Okay, so RAID 0 is called as striping. You can see here, right, striping. So here, what is this RAID set? This is basically group of disk, right? So here you are writing the data. Okay, so what you can see here, you see the blocks, right? So these blocks, so you are actually writing the data on some like sequential or contiguous blocks, right? And you call this as strips. Okay, strips. Okay, and these strips are basically spanned across multiple disks, right? So these are called as, together these are called as stripes. Okay, stripe. Okay, you can see this representation, right? And the strip size, or you can call it as like stripe depth, right? It will depend on the number of blocks in a strip, how many number of blocks are there. Okay, so normally here in RAID 0 you can see that the data is being striped across all the dips in that RAID group, right? So this block 1 is only 1, so if you lose this, you lose this. So it's like you do not have any redundancy here. You do not have any redundancies here. So this stripe RAID, it is not protecting the data. Okay, so but the input performance is much better. Okay, because it's like sequential data, and this input IO performance is good, but you do not have any redundancy, because you see the block is, if this block is get corrupted, right, you do not have any way to protect it. Okay, so IEEE, they came with different concepts. One is mirroring, so to have duplicate data, and another one is to keep parity. Using parity, what they do is that they do XOR operations, and then they rebuild the failed data. Okay, in NetApp I will show you a scenario where I will show you, I'll fail a disk, and then I'll fail a disk in the aggregate, and then I'll show you that how spare disk became the part of that aggregate. Then what I'll do, I'll replace the disk, and I'll make that, because sometimes what happens, that client or project requirement is that whichever location the disk or the failed disk was there, right, you need to replace it, and that will be part of that aggregate. So we'll do the active copying of data, and that disk will be part of that aggregate, and then we'll fail the spare disk. And once the spare disk is failed, right, if it not failed, I will remove that from the aggregate. Okay, so one is becomes spare, right, and in future if you want to use the spare disk, we will not be able to use it until unless we write zeros on it. We do disk zeroing. So all these things I will show you practically, and this is very important because this question will get asked in the interviews. Okay, so here what you are doing, this RAID type of implementation, we do not have any redundancy. Okay, only striping across the different drives. Okay, so here we are having the RAID 0, which is having 2 drives. Okay, minimum 2. Okay, now let us talk about RAID 1, which is mirroring. See, we are not going to use RAID 0 or RAID 1 for ONTAP, physical ONTAP, but yes, for software defined storage array NetApp, we'll be using RAID 0. Why? ONTAP select RAID 0. Why? Because ONTAP select is software, is just a software. We are using the hardware of different physical storage such as Hitachi or EMC or even NetApp and ESX infrastructure. Okay, so in that storages like Hitachi or EMC, right, we already have the RAID implementation. They have storage pools, they have RAID implementation there. We don't want to do RAID again in NetApp, because more RAID means you losing the usable space is becoming lesser and lesser. You're losing you're losing the space to parity disk. You don't want that to happen. Okay, we want to have more space to keep the user data. Okay, so my old students, did you understand why you use RAID 0 in on-tap select write? Sutish, Adnan, you understood, right? Palash is on hold. Nikhil, why use RAID 0 in on-tap select write? You understood, right? This thing. Why not RAID DP, RAID for RAID TEC?
Yes, sir.
You understand?
Yes.
Yeah. And recently I had one issue. Okay, so in NetApp, what you can do is, suppose you are having your data volumes and everything, data servers and everything, and you can create audit confession also. Audit confession to track the audits, like which user is doing what, like which user is deleting files in SFH, everything. We can do the audit confession also. So I did it for one of the like many arrays in our environment, but for one array it was not happening. So I redeployed the array again. Okay, and like I did everything. The errors were there, like using the space, increasing the space, even change the junction point, even pointed that, everything I did, but it did not happen. So I redeploy the cluster. So sometimes you have to redeploy. So whatever bigger things you are doing, right, you have to do it at the transformation phase, not the production phase, because then you do not have a way to turn back, to the original condition. Okay. So let us show you the mirroring. RAID 0, RAID 1, sorry, RAID 1. And for the past 2 or 3 days, right, I'm having a lot of issues in Hitachi. There is some microcode bug is there in VSP 1 block array, due to which half of the disk failed. They reinserted the disk and the issue, was resolved. But again, we need to do, they need to do something to fix the bug. It never happens with Hitachi, but anyway. So let us discuss about this. Mirroring, right? So what is mirroring? So using mirroring, what you are doing, we are storing the data on 2 different hard disks. Okay, so you're having 2 copies of same data. So in the event of one hard disk failure, the data is still there in the other hard disk, right? The survivment is right. So whatever host request is there, it will be able to give, right? Because we have the this rejoin again as it is free teams. Okay, 1 second. So I think everyone joined. Yes, I give some time to people. Yeah. So thing is, we are using free teams here. So free teams will automatically get disconnected after 1 hour. So you need to rejoin. So that's what happens. Okay. My old students knows it, but I'm just telling. Okay. So you can see here. So this is mirroring, right? As I said, the mirrored pair will be when this drive is filled, the same data is there in the other disk, and then the data is there. Okay. And when you replace this failed disk, right, with a new disk, the RAID controller will copy the data from the remaining, the surviving disk. Okay, it will copy to the new disk, the spare disk. Okay, and this copying the data, right, it is transparent to the host. The host will not know. Okay, so what is happening? Because of the mirroring, you can get faster recovery from the disk failure scenario. Okay, So you have to understand that, okay? So this disk mirroring is like it's having duplication of data. So suppose you are actually losing out of half of the, half of the disk, you are losing out half of the space, right? So suppose you have 10 TB of data using for mirroring RAID 1, you're using RAID 1, so you're only able to use 5 TB of data, right? Because 50% of data, you are just duplicating the data, right? So here normally, for mission critical data that we cannot really afford to have any data loss, so there we can use RAID 0. Here using mirroring, it is improving the RAID performance because the read request can be serviced by any of either of the disk, okay? But whenever you are using, when suppose the application is a write intensive application, there are many write IOs, there are more write IOs compared to read IOs, okay? So what happened? One write IO means two write IOs, so you're getting more write IOs, right? Which is not good. So the write performance actually is deteriorating, okay? Because you have to write two writes, okay? So in that case, striped RAID is the RAID 0 is better, but as I said, RAID 0 it does not have redundancy, okay? It does not have redundancy, okay? So then I will talk about another thing which is called as parity. Let us discuss about this parity. Okay, it's not showing anything anyway. So basically, parity is basically you are having the stripe data, right? You want to protect the stripe data from the hard disk failure, right? So without having the mirroring, because if you have mirroring, you're losing half of the data to have the mirror disk. So in order to use in order to use have more usable space compared to the mirroring, compared to RAID 1, we can use a technique called parity, okay? So what you'll have, we can have an additional hard disk which will have the parity, okay? And whenever some disk is lost, then we can use that parity disk to mechanically I'd say mathematically, like XOR XNOR operations, to recreate the missing data, okay? Recreate the missing data we can do. And the parity information, it can be on a separate hard drive, it can be on a dedicated hard drive, it can be on a distributed hard drives in a RAID set, depending on what kind of RAID you are using, okay? Suppose you're using RAID drive, then you will have a dedicated parity disk. If you're using RAID 5, like RAID 4, you'll have a dedicated parity disk. You're only protecting as one disk failure. RAID 5 also one disk failure, but the parity data is striped across all the drives in the RAID group, okay? And RAID 6, it will have dual distributed parity. And then you can have RAID like nested RAIDs like RAID 10, RAID 01, RAID 50. I'll discuss about that, okay? So let us first discuss about RAID 4. I hope you are able to understand my concepts, right? I will be able to understand my concepts. See, RAID 2, RAID 3 nobody uses, okay? So let us discuss about RAID 4, okay? But RAID 4, because we use RAID 4 in NetApp. I think this is a better picture. I think this is a better picture here. Okay. So RAID 4, basically here the data will be striped. You can see the data is striped across all the disks, right? A, B, C, D, E, F, G, H, I. It is striped across all the drives except the parity drives, which is basically your dedicated disk here. The parity information, the P1, P2, P3, it is basically stored on a dedicated drive, and whenever one of the drive fails, these two drives will do some XOR XNOR operations, mathematical calculation with the parities, and this data will be regenerated, okay? It will be generated, okay? So, and this RAID 4, what it will have good read throughput, okay? Because you can see the stripe across data, so good throughput. And write throughput will be little bit slower because whenever data is changed, it has to change the data, it has to change the parity also. So you'll have more IOs. For one write IO, you'll have more write IOs, okay? So there will be some write penalty. Write penalty means whenever you do some writing or changing the data or anything, right? So how many write will happen for one write IOs, okay? So that is called write penalty, rate penalty. Okay, I will discuss about that, okay? So what you are seeing here in RAID 4, you are seeing it's like dedicated parity disk you're having, and NetApp is, the ONTAP is using it. So in ONTAP you will have RAID 4, RAID DP, and RAID TEC. Okay, so whenever you're installing NetApp, by default the root aggregate, which will have the ONTAP operating system of your nodes, right? So that will be RAID DP, dual parity. Two disks you lose because of to keep the two parities. Okay, and RAID DP is for dual parity, two disk simultaneous disk failure protection. So if two disk fails in the RAID group at the same time, you are still protected if you're using RAID DP. If you're using RAID TEC, triple parity, triple encoder encoding, I think I forgot the full form. I need to check. Okay, nobody will ask you, but RAID TEC is for three. It will have three parity disk. Okay, so it can protect against three simultaneous disk failures, so you can use either of this. Normally RAID DP will be used for your root aggregate, which will have your ONTAP operating system, and for data, where you cap the data, like for the SAN data, NAS data, object data, we'll use either RAID 4 or RAID TEC, depending on what your, or RAID DP also you can use if you want. So depending on what is the requirement in your project. Because see, if you're having more parities, your performance also, the write performance will also decrease, right? So you need to take care about that. Okay, so let us discuss about 8.5. So RAID 5 you can see here, right? RAID 5 is basically, it is similar to RAID 4 because it also uses striping, it also protects against one disk failure. Okay, but there is a difference between this. What is the difference? The difference between RAID 4 and RAID 5 is the parity location. Because in RAID 4 we're using single disk to keep the parity. Okay, but RAID 5, the parity is distributed across all the drives. Okay, and wherever you are using, suppose in RAID 4 you're using the parity on a dedicated drive, right? So it is having a bottleneck for the parity disk, right? So what if we lose the parity disk, right? So it will have problem, right? But to overcome that problem, RAID 5 was invented. Okay, so RAID 5 was, so we can, the data is being actually stripe. I can see here A1, B1, C1, and this is your parity. A2, B2, this is the parity, and this. You can see the parity bits are distributed across all the drives in the particular RAID group. Okay, if you lose this RAID group, sorry, if you lose this drive in the RAID group, then if that's paired disk, if you have some paired disk, you can make that will be part of the RAID group, and the data from the surviving disk and the parity, the data will be generated. Okay, so you have to understand that, which is a very easy thing. And let me talk about RAID 6. We use only RAID 6 for E series, NetApp E series array, not for any other NetApp arrays. Okay, so you can see here RAID 6. RAID 6 also quite similar to RAID 5. The only difference is that it is having a second parity. Okay, you can see here second parity is there, DP EP, CP DP, CP DQ, something like that. Okay, you can see here. So what happened if you having two disk failure at the same time in the same RAID group? Still the data will be intact because you are having two parities, dual parities. Okay, so this RAID 6 will need at least 4 disks, okay, to implement this. And in RAID 6 similar to RAID 5, the parity will be spread across all the drives in the particular RAID group. Okay, so tomorrow we'll discuss about nested RAIDs, RAID 10, RAID 01, RAID 50, RAID DP, RAID TEC, RAID, and the write penalty. Okay, write penalty, I will show you that why NetApp is using RAID DP and RAID TEC, why they are not using RAID 5, RAID 6, because the write penalty is much better. And I also show you how to do the IOPS calculation for a storage aggregate. Okay, so tomorrow we'll do that. Okay, and then once the storage basics are over, then we will go to the SAN switches, Once the SAN switch is over, then we'll go into the NetApp topics. Okay, there are lot of NetApp topics is there which we need to cover. So let me show you one thing. 1 second. Why it's not coming? Yeah, it is coming. Okay, so basically we'll give you the storage basics. Okay, once this is done, we'll show you in SAN switches. I will show you how to do zoning, how to do trunking for e-ports, what are different kind of ports are there, how to do, how to do LSAN zoning, why LSAN zoning is required, how to troubleshoot the credit store devices, BB zero credit issues, some port error issues. Okay, those things, how to check the name server. Uh, so these things I'll show, and how to do the virtual fabric creations. All these things I'll show you. Okay, I'll teach you.
So,
Okay, except the switch.
yeah, I have a
Yeah.
question. I am unable to see day 1, day 2, day 3. Is there any access I need it, or how do I see that one? Like you are showing me very clearly
Okay.
storage,
Okay. Let
storage
me.
session 1, 2, 3, 4, right? Yeah.
Okay. Okay. Let me just stop the recording here. So any questions before we wrap up? I'll then I will ask you to share your screen. Okay. So any question? Do you have, my brothers and sisters? Do you have any questions for today's class?
Yeah, I Daya. Hello.
Yeah.
Yeah, Daya.
Yeah. Yeah.
Today, yeah, today we'll start the class and starting onwards, and we should have process what we have to going on basic classes and SAS, FAS, and SAL. Something. What did you need, sir? Or, story basic. I want to miss on this one, but again we can learn on this. Nothing.
Okay, no problem, no problem. See, what you can do is that I'll give you access to the channel. You need to study that, and if you have any question, you can ping me on the group. Okay,
Okay.
you can ping me over the group.
So,
Okay, no problem. It's very easy, bro. Today's session was very easy. The reason I created the storage fundamental playlist, okay, but it was actually not required that much. Okay, this very like 12 basic sessions I've given here. Okay, in storage fundamentals. Not it is not required, but I give like very intensively. You can go through the sessions. Okay,
okay.
every session will like 1.5 hours. Normally they don't ask you much, but I gave like a lot of stuff. Okay, so what you need to so you just need to understand that. And anyone having any other questions? Okay, so basically I teach the storage basics first, then I will go into the switch sessions as I said. And you, the switch session that I give, right, you will be able to clear healthy interviews also with that. You will understand. Okay, you just, if you have time today or tomorrow morning, right, you can just go through the sessions that I've given, and then I'll teach you the NetApp architecture, the waffle architecture, the file system architecture in NetApp, how the IO happens, and then I'll go to the more physical virtual components, networking components, CFS share, NFS share, iSCSI, and Occam configuration of Occam, which is a monitoring tool. What are the issues we get in Occam? How to do on-tap upgrade and how on-tap downgrade. Suppose you did upgrade and because of upgrade you are getting some issues, you need to revert it back. How to do that? How to do the volume level snap mirror, the tier testing, okay, of different kind of issues, snapshot configuration, system backup configurations, different kind of non-destructive operations, auto support configurations, okay, QoS policies, flash cache. So these are write penalties. See, this is only for the L2 I'm saying. Okay, for L3 there'll be much more. Okay, uh, this is one batch. In this batch I did not give CPU. This batch I'll do CPU. Okay, CPU means cloud volume on time. Here I gave CPU, yes, but only for Google. I didn't give for AWS and Azure, so that I will do in this batch. So you can check here. So what are the things I've given to you? Okay, given. Okay, you can check Metro cluster, everything, 7 mode to C mode migrations, SVMDR, okay, flex group, flash pool, okay, storage grid, all these things. Okay, okay, all these things. Okay, okay. So